If a given relation is also a function, we will often replace y with the symbol here, which is read f of x. We call this symbol function notation. So I want to get some practice with it in this lesson, and let's start by taking this equation and sketching its graph, but using this notation instead of using this y. So if you remember from our previous lesson, our approach was to graph this, solve for y, choose some x values, and plot those points. If I solve this for y is equal to negative 2x plus 6. But the only difference here is, instead of writing y, I'm going to use the symbol f of x. All right, so the way this works is, I'm going to choose a value for x, I'm going to plug it in place of every single x, and then simplify this side. You can choose any x value that you would like. I think I'll just pick maybe 2 or 3 different ones to see if we can get a graph. So I'm going to start with negative 2. I'm going to put negative 2 in place of all of the x's and simplify my expression. What this will do for us is, at x equals negative 2, we're going to figure out what the corresponding y value is. So we have negative 2 times negative 2, which is 4. 4 plus 6 is 10. This simplifies to f of negative 2 is equal to 10. Or said another way, if x is negative 2, y is equal to 10, written as a point. So at negative 2, we get 10. So just keep in mind that this and this are saying the same thing. This one's a point, this is in function notation. So let's get maybe a couple of others. How about what happens at x is equal to 0? What I'm going to do is put 0 into all the x's and simplify my equation. So let's see. F of 0 is equal to negative 2 times 0 plus 6. When I simplify this, negative 2 times 0 is 0, plus 6 gives me just 6. I have that f of 0 is equal to 6. Or said another way, that's the point 0, comma 6. And if I graph that, that's located right there. Let's get one last point. How about, what's the value at 3? For that, you take 3, you put it into the function, meaning you're just putting it in place of all the x's. And when I simplify this, I get negative 6 plus 6, that's just 0. So I get f of 3 is equal to 0. That's the same thing as the point 3, comma 0. If I plot that, that's located right here. And my equation is just the thing that goes for these points. I think this is just going to be a line. I'm going to try to draw that as best I can. Let's see. So something like this. There it is. Getting the graph really wasn't the big idea here. The new thing is just understanding what this notation means. It's just another way to represent our function. For example 2, I just want to get some more practice using function notation. So down here on our graph, I'm going to call that the function f of x. It's definitely a function. And I want to see which of these statements are true. Some are true, some are false. And what we're going to do is see if we can interpret this and find it on the graph. So let's start with this one here. F of negative 1 is equal to 4. So what this means is, at negative 1 for x, the y value should be 4. Let's see if that's true. So here's negative 1 for x. If I put that into the function actually is equal to negative 6. So this is false. This is not true. And the reason is, this means the point negative 1 comma 4, and that is not on our graph. Negative 1 comma 4 is located here, but if you're looking at negative 1, it actually goes down to negative 6, so that one's definitely not true. So let's see if this next one is true. Is f of 2 equal to 3? Meaning, if you put 2 into your function, does it give you 3 back for y? So let's see. Here is 2. I evaluate that in the function, and it goes up to 3 places. Okay, this one is definitely true. This is true because if you put 2 in place of x, you get 3 back for y. Perfect. All right, what about f of 0 is equal to 1? So that means I go to x equals 0, and I don't get 1. In fact, I get -3. So this one is definitely false. Okay. This is false. The point 0, 1, that's not on the graph. All right, what about this one here? What about f of 1 is equal to 0? Again, this means you're putting 1 in place of x, and it's saying that the y value is 0. So my x value is 1, the y value is definitely 0, and that's true. We have the point 1, 0 on my graph. So if you compare the two that we just did, it can be easy to confuse these, but 1 represents the x that goes in the function. The thing that's over here represents your y value. Okay, what about f of 3 equals 0? So that would be 3 for x, 0 for y. Okay, that's definitely false. 3, 0 is not on my graph. And then the last one here, f of 0 is equal to -3. So here's 0, and okay, we've already checked this one out before. -3 is definitely the y value, so this is true. That's the point 0, -3. So I guess the thing we're trying to get across here is, if you say y is equal to f of x, this is saying you have the point x, y. The thing that goes in the function is the x value. The number next to it over here represents the y value. And in example 3, just another variation on some practice using function notation, but this time solving a couple of equations. Here we have a graph which I'm calling f of x, and I want to use this graph to solve these 4 equations. Let's start with this one here at the top. F of x is equal to 7. The goal is to find an x value for when the y value is 7. To solve this, you have to look at your graph and figure out where the y value is equal to 7. So we have to kind of work backwards here a little bit. But this is a y value of 7, right? 5, 6, 7. You have to look left or right. There's nothing over here, but if you go to the right, the graph meets at this point here. So this is where your function is equal to 7. To solve our equation, you just have to look down to the x-axis, and I see 5. So just reading this off of the graph, I know the solution here is x is equal to 5. And the reason is, if you put 5 into the function, it gives you 7 back as the y value. So really, we're just reading things off of the graph. But if you check out this next equation, it's really similar. There's a 7 over here, but I've changed the inside from x to x plus 1. How does this change things? So let's see. My y value is 7, which is still here. And if you go over to the function, the corresponding x value should be 5. But this is a little weird. In our previous example, when we were solving f of x is equal to 7, our goal was to make the inside equal 5, because I know that's true. But here, you have an x plus 1. So the question is, what would I put in place of this x if I want the thing inside the function to equal 5? Here, let me write that off to the side. I mean, now we have this x plus 1 is 7. I want this thing to be 5. So what would I put in place of x to make this thing equal 5? It's a little strange, but x would have to be equal to 4. I want to check to see why this is true. If you put 4 in place of x, when you add 1 to it, it gives you 5, and we already know that f of 5 is equal to 7. So for the second one here, the answer is actually 4. It's weird. If you add 1 here, you actually have to subtract 1 to get the correct answer. So going up 1 here meant we're actually going down 1 here. So let's now check out this next one down here where f of x minus 1 is equal to 7. But the same idea holds. My goal is to figure out what do I put in place of this x so I make the thing inside the parentheses equal 5. Well, if there was a plus 1 and 4 added us back up to 5, the answer here would have to be 6. Let's see why. We have f of x minus 1 is equal to 7. This whole thing here should be 5 for it to work out, but that means you have to put 6 in place of x. Because when you simplify 6 minus 1, it gives you 5, and f of 5 is 7. All right, so if you're adding 1, the answer goes down 1. But if you're subtracting 1, the answer goes up 1. It's the opposite of what I would expect. So let's see if we can figure that out for this very last one here. All right, f of x minus 3 is equal to 0. Okay, this one's a little bit different. Let's see. I first have to figure out where is the y value equal to 0. So here's my function, and it has a y value of 0 right here. So this is the point I'm referring to. That's where f equals 0. And the x value there is -2. On my original graph, -2 gives me 0 back for y. But over here, we have x minus 3. What number would I put in place of this x? So x minus 3 is -2. And the answer in this case is going to be 1. The reason why is, if you put 1 in place of x, you get 3 minus 1, which is -2, and f of -2 is 0.